Good morning. Let us start with today's session. So let us start with the term queuing theory, with the topic queuing theory. So before that, let me portray one pic and ask you what do you know about this pic. This is a very famous pic of one movie.
ये जहाँ खड़ा होता है वहीं से लाइन लगती है.
Yes, very good. So what I want to say here is this concept is not followed in this particular topic. In this particular topic, what is the assumption? The assumption is the queue is already there. There is queue. There are some people waiting, and all the people who want service should follow some queue discipline. Okay. जो भी बंदे को क्यू में कुछ काम करवाना है उसको क्यू डिसिप्लिन फॉलो करना पड़ेगा. नो वन फ्रॉम आउटसाइड और समवन व्हिच इज स्ट्रॉन्गर देन यू कैन कम इन बिटवीन एंड टेल दैट अब लाइन यहाँ से शुरू होगी. सो दिस इज नॉट द assumption. Assumption is line is already there. There is already a system existing, and all the persons in the queue or all the entities in the queue should have to follow the discipline of the queue. And what is the discipline? Let me give an example. Let us say one of the discipline of queue is FIFO. FIFO means first in, first out. First in, first out means those who comes first will get the service first and will leave the system first. So this is one of the discipline. There are many more which will be seen in our later slides. Okay. Now, answer again from your side. What do you mean? What do you mean by this term Q U E U E? What do you mean by this term? What can you understand by this term Q?
Sequence, एक sequence में.
Okay, very good. Okay, I will take this term a sequence. Okay, anyone can add on it?
One by one.
Okay, good.
Standing in arrangement.
Standing in arrangement. Okay, okay. So let me take all the words given by you and frame one sentence which will be nothing but the definition of queue. So someone said it's a systematic arrangement. Someone said waiting for the turn. Okay. So let me give you a definition. The correct definition. I will be using the words given by you only. Okay. So the definition goes like this: queuing system or a queue. It is a system in which, okay, understand this word, the definition of queue. It is a system in which the entity waits. Okay, it's not only the person, anyone can wait. Okay, for example, let us say one machine has been broken down. So it has to wait for its service. So there the person or the entity which is waiting is the machine. So it is not always the person who are waiting. There can be any entities also who can be waiting. So in general terms, we take it as entity. So system in which the entity is waiting for their turn. Okay. Again, I will repeat. System in which entities are waiting for their turn to get the desired service. That's it. So that's the basic definition of a queue. So again, I repeat the entire definition. It is a system in which entities waiting for their turn to get the desired services. Should we move forward? I hope you have got the definition.
Yes, sir.
Okay.
Yes.
Okay, so let us now go towards what are the different types of queue or how can we classify types of queue. Again, I will take an example. Can you identify this pic? Yes.
Yes,
Anyone
sir.
can
It's
identify. It's
Dr.
very
Hello,
simple.
sir.
It's a medical or you can say it's a doctor pic. So here I have taken an example of a clinic. Okay, I have taken an example of a clinic. Let us say the service provider is a doctor, and who will be the entity here? Entities कौन रहेंगे?
Patients, na, sir.
Yes,
Patient.
the patient will be entities. Okay, so what happens here? As I told in the definition, there are some persons. So there are three persons who are standing in the queue, and they are waiting for the service. So that is nothing but a queue line which is already there on the left hand side. Now what will happen? This person will come here. That means he will be getting the service. And after getting the service, he will be moving out of the system. So this entire scenario is nothing but the queuing theory. So what is happened? What is happened here? There is a formation of queue. Then one person will get the service on at his desired time, take the service, leave the system. So that is nothing but the entire queuing process. Okay. So one more example I have taken here. So there is some images here. So you can see here there are customers arriving. They are waiting for their turn, and while waiting, they are listening to music. Someone is chatting, etc., etc. Then they will get the service by the facilities available, and once they get the service, they will leave the system happily because they are served customers. So here you can see there are served customers. Now, the point which I want to highlight here is here you can observe that there are many persons in the line. The queue can be anything. There can be any person in the line. But can you tell me how many persons are there for service in this example of doctor?
एक आदमी दे रहा है
Yes,
डॉक्टर
the person who is giving the service is only one. There is only one doctor giving service to many other patients. So this kind of model, when there is only one server or there is only one service provider, this type of problems are, or this type of models are known as single server model. So here it is written single server. So any doubts in this? What is a single server model?
नो सर
Okay. So if there is only one single service provider to many, then it will be known as a single server model. Now, can you predict what will be my next model?
मल्टीपल सर्विस
Multiple server. You have guessed it correct. Oh, okay. Let me ask you the example only. Can you give me an example? Have you seen the multiple server model?
Ticket counter.
Ticket counter. Yes. Very good.
Counter.
Very good. The best example is a ticket counter. Railway ticket counter बोल दो आप, bus ticket counter, anything you can take an example. Okay. So you have got the concept. I have one example, let us say, of banking. So most of you have visited the bank. Yes or no? कुछ काम से
Yes, sir.
scholarship वगैरह के जाते
Yes.
आते रहते. So what happens here is you enter into the bank and you stay in the queue, and now there is a system of a coupon. So they give you token number and you sit somewhere, and then on the screen they display the number. Okay. So they will tell token number, let us say 11, go to counter number 1. Token number 12, go to counter number 2. So as the counters are getting empty, they send the person to that particular service stations. So what I mean to say here is queue is only one, or they can be persons waiting, but there are multiple service station. बैंक में जाओगे तो बहुत सारे काउंटर रहते हैं अलग अलग, 1 2 3 4 5 6 7 8. So let us say there are 3 counters. So what will happen if this counter is free? Let us say this counter number 1, counter number 2, and counter number 3. So they are getting service. Now let us say, assume that this person has got the service and he is leaving the system. He is getting out of the system. So now this counter is empty. So what they will do, they will display this counter number 1 for the next person. So what this person can do, this person can go here. But before this gets empty, if this gets empty, then what he will do, we will go to this counter. Yes or no?
Yes, sir.
So the one who is standing at the front can go to any of this counter for this service. Okay, whichever counter is empty, he can go to that particular counter to get this service. So what is happening here? There are multiple service stations. For one person, there are multiple service stations. Hence, this kind of models are known as multiple server models.
पेट्रोल पंप
Petrol pump, yes, that can be also example. There are many petrol pump stations and they are giving the service to the customers. So that can be also example of multiple server. So any doubts in single server and multiple server? In short, I can tell in single server there is only one service provider, and in multiple server there are multiple service provider, or within more than one. Now let us go for the further classification. Now, as we have seen, it is queue is further divided into single server and multiple server. These are again further divided into some parts. So this we have already seen. What do you mean by single server and what do you mean by multiple server? This we have already seen. Now this has been further divided into something. And what is that something? Again, I will show you the pic, and from that we will fetch the answer. So this is the pic in front of you, and this is the pic in front of you. So what can you tell about this pic? What can you assume about this pic? Okay, let me give you a hint. What can you tell about the length of queue?
नीचे वाले इमेज की लेंथ ज्यादा है और वहीं बस की और जो लाइन है पब्लिक की वो कम है लिमिटेड है सर
Okay, limited. Okay, I will carry forward your discussion only. In the first image, you said that the line is limited. So can you restrict anyone to stand in the queue? आप किसी को रोक सकते हो?
जब बस फुल हो जाएगी तब रोकना पड़ेगा.
वो तो अंदर घुसने के लिए ना, लाइन लगाने के लिए रोक सकते हो क्या?
नहीं.
अपन क्यू के बारे में बात कर रहे हैं ना अभी. तो मैं अभी जा रहा हूँ, भले बहुत बड़ी लाइन लगी होगी, अभी सपोज ट्रेन वगैरह बंद है तो बस स्टॉप से ज्यादा लाइन रहती है, तो कोई मुझे रोक सकता है क्या बस की लाइन लगाने के लिए?
नहीं रोक.
मैं बोलूंगा ठीक है, पहली बस में जगह नहीं मिलेगी, दूसरी तीसरी चौथी पांचवी में 3 घंटा भी खड़े रहने को रेडी हूँ. सो कैन एनीवन स्टॉप मी फ्रॉम in this to go in this queue?
No, sir.
So can I tell that this queue length can be infinite?
Yes, sir.
Yes, sir.
कितनी भी लग सकती है ना, मैं रोक नहीं सकता हूँ. So this
हाँ,
is
sir,
the
हाँ.
this is the division. So single server model and multiple server model are further divided into finite and infinite queue length. Okay, so these two are the examples of infinite queue length model, wherein I cannot restrict any person to join the queue. It can be of any length. Okay, now again you can predict what will be my next one.
Finite.
Finite. Okay, now can you give me an example? What can be example of finite? I will give you one hint. मैंने फर्स्ट उसमें डॉक्टर का एग्जांपल दिया, बराबर. अभी
Yes.
देखो, जो नॉर्मल डॉक्टर्स रहते हैं वो मतलब क्लिनिक खोल के बैठ गए, उनके पास आना जाना लगा रहता है. बट दोस हु आर बिग डॉक्टर्स, जिसके नाम चीन है, अब वो क्या करेंगे? आई विल कम इन दिस पर्टिकुलर प्लेस ओनली फॉर 1 hour एंड आई विल बी एग्जामिनिंग ओनली 5 पेशेंट्स. कहीं देखा है ऐसा केस?
हाँ सर, हॉस्पिटल्स के अंदर
yes, बड़ी बड़ी हॉस्पिटल्स में जब तुम जाते हो तो क्या होता है, नीचे बोर्ड लगा रहता है, दिस डॉक्टर विल बी कमिंग ओनली ऑन मंडेज फ्रॉम 4 to 6. और जब आप केस पेपर निकालने जाते हो सो दे विल टेल ओके आज के लिए 5 पेशेंट थे 5 पेशेंट हमारे हो गए, अब आप लाइन में नहीं लग सकते हो, डॉक्टर इसके अलावा छठे पेशेंट को एग्जामिन नहीं करेंगे. यस और नो? ऐसा कभी केस हुआ है आपके
Yes,
साथ?
sir.
नहीं हुआ होगा, बट हैव यू
हाँ,
हर्ड
sir,
अबाउट
हुआ है.
दिस लाइक दिस?
होता है.
सर हुआ क्या, एक्सपीरियंस भी कर चुका हूँ.
ओके, एक्सपीरियंस भी कर चुके. इट्स अ बेसिक इन जनरल ऑल हॉस्पिटल्स में ऐसे होता है. ओके, नाउ कैन यू गिव मी अनदर एग्जांपल ऑफ दिस? So this is the finite queue length. चलो ठीक, let me give you an example, and the example is like this. Okay, let us say some one of you own a garage or a car washing station, and as a customer I have come to you to get my car washed. Okay, so now let us say it's the opening time and there is no queue. I have parked my car and you have started servicing on it. Okay, there was no queue and you have started the servicing on my car. After some time one more car has arrived. Okay, थोड़ी देर बाद एक और कार आ गई. So can it go directly to the service?
No.
No, it has to wait in the queue. It has to wait in the queue till the first car has completed the service. Yes or no?
Yes, sir.
Okay, so this car, let us say this second car, one car is getting serviced here, and let us say this second car is waiting for its turn. Okay, and in the meantime let us say the third car also arrives. Let us say the third car also arrives. So, and I will give you that the space available with the garage, it can accommodate only 2 cars. Okay, I am giving you the condition. अब garage इतना बड़ा तो होगा नहीं, road side का car washing station है, it can accommodate only 2 cars. So will he allow the third car to be in the queue? जगह है उसके पास?
नहीं allow
जगह नहीं है. ठीक है, what he will tell, थोड़ी देर बाद आना है, जब भी आना है बाद में आओ. अभी आप लाइन में नहीं लग सकते हो because I don't have space. मेरे पास स्पेस एक ही कार जो वॉश हो रही है उसके लिए है और एक कार खड़ी रह सकती है बस क्यू में, दूसरी के लिए मेरे पास जगह नहीं है. ओके, सो व्हाट बाय दिस कंडीशन व्हाट ही इज डूइंग, ही इज रिस्ट्रिक्टिंग द लेंथ ऑफ क्यू टू ओनली 1 कार. ओके, माइंड माय वर्ड्स, ही इज रिस्ट्रिक्टिंग द लेंथ ऑफ क्यू टू ओनली 1 कार. क्यू में एक ही कार है, 1 कार इज इन सर्विस. सो हियर ही हैज लिमिटेड द नंबर ऑफ कार्स to 2 or the number of cars in queue to 1. So this kind of cases are known as finite queue length models, wherein we ourselves restrict the queue length. And the best example again, what all you have told that about the doctor. That's the basic example. In the hospitals you go, they don't give you case papers or the paper for examination. They will tell for today the quota is over. Okay. Okay. So till now what we have seen the definition of queue. Then we have seen the single server model, multiple server model, infinite queue length model, and finite queue length model. Now, this is being further divided. This is being further divided into another 2 parts. So again, I will have some pics and will explain you what do you mean by that. Okay. So we have now seen what is infinite queue length and what is finite queue length. Okay. So can you tell me what is this example for? Ticket counter. Good. So is it a finite queue length or infinite queue length?
Infinite queue length.
Yes, it will be of infinite queue length. It is a problem of infinite queue length. The line can be anything. They will close the counter. अब जो line में लगे थे वो घर जाओ. But they will not restrict anyone to be in the queue. Okay. Now tell me. Okay, let me give you an example. Tell me, can you go and get the ticket from the ticket counter?
Yes, sir.
Yes, sir.
Okay. Okay. Instead of you going, can you send any one of your family members to go and get your ticket?
Yes, sir.
Yes. Okay.
Yes,
Can
sir.
you send your worker and get the ticket?
Yes, sir.
Yes.
Yes, sir.
Okay. Can someone who is coming from out of India, let us say he is coming from US or somewhere out of India, and he wants to travel locally, can he get the ticket from the counter?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
So what I want to try and say is here, it is an infinite population. Infinite population. Infinite population means anyone can go and take the service, whether it be a boy, a girl, a man, or senior citizen, a foreigner, a Indian, a youngster, a adult, anyone. So there is no restriction on the population side. Male, female, anyone can go. So there is no restriction. Hence, this type of model is known as infinite population method. Understood?
Yes, yes.
Okay. So what will be my next?
finite population.
Finite. Okay. Can
Finite
you give me the
population.
examples?
So मेरा फीस काउंटर कॉलेज का
Very good example. Best example. अच्छा, कोई दूसरा बाहर की कॉलेज का बंदा आके अपनी कॉलेज में फीस भर सकता है क्या?
नहीं भर सकता जब तक उसके पास आईडी कार्ड नहीं है वैलिड।
लेट अस से वो बोलेगा सर मैंने बाजू की कॉलेज में एडमिशन लिया पिल्लेज में और मैं फीस यहाँ आके भर दूंगा, चलेगा कैसे?
नहीं सर,
नहीं चलेगा.
नहीं चलेगा, बराबर. और मैंने तुमको एग्जांपल दिया कि आप लोग का एग्जांपल में ले रहे. लेट अस से you all are the persons who are taken OR as the subject elective. So can any other person come and give the unit test of operation research or give the exam of operation research?
नहीं
No.
सर.
नहीं आ सकता. So what I am doing, I am confining myself to finite population. Finite means I have restricted myself to only those who can come, who will be taking OR, or the ones who are in this college can only come and pay the fees at my fees counter. No other person from outside can come and pay the fees or can avail the concession or can avail the ID card, anything. Logic समझ में आ रहा है?
Yes, sir.
So these are the cases of, so this is the example of a fee counter of a college. So here I can say that it is a finite population method or finite population model. So let me test your knowledge. I will put some pictures in front of you and I want the answers from your side in three words or three different answers. The first answer should be, is it a single server or multiple server? Okay, this should be your first answer for the same pic. Second question, second answer should be, is it a finite queue length or infinite queue length? And third answer should be, is it a finite population or infinite population? So for every pic I show, I want three answers from your side. Okay, so be ready. Let us go for the first pic. So as we have discussed, this is the single server, infinite queue length and infinite population model. Okay, let me go for the second pic. Okay, so this is the pic which you are familiar with. So can you tell me these three answers?
मल्टी सर्वर है ये,
Yes.
फाइनाइट क्यू है और फिर रिस्ट्रिक्शन नहीं है इसमें.
One of the answer is wrong.
Infinite.
Yes. Multiple
Infinite.
servers, because you can see there are multiple windows. It should be multiple queue length. As I already told, आप किसी को भी लाइन में लगने से रोक नहीं सकते. मेरे को टिकट लेना है, 100 लोग आए, 500 लोग आए, 1000 लोग आए, they can be in the queue. So you cannot restrict the queue length. So it will be infinite queue length and anyone can go and take the ticket. Hence it is a infinite population model. So it will be multiple server, infinite queue length and infinite population model. Okay, let us go for the third pic. Okay, can you tell me about this? A good example. Let us see whether you can give the answer.
सर अगर इमेज के हिसाब से देखें तो यहाँ पे मल्टी सर्वर है, 2 मैकेनिक है अपने पास, फैकल्टी है जो रिपेयरिंग के.
Very good.
और
वेरी गुड. मुझे यही बताना था कि बच्चे यहीं पर मिस्टेक करते हैं. ओके, सो इट इज अ सिंगल सर्वर मॉडल. व्हाई सिंगल सर्वर? अब देखो, अब लॉजिक समझो. व्हाई इट इज अ सिंगल सर्वर? मैक्सिमम ऑफ यू थिंक लाइक यू ओनली. जो आपने बोला ना, दो लोग को देख के बोल दिया मल्टीपल सर्वर. इट इज नॉट लाइक दैट. इट इज अ सिंगल सर्वर. ओके, okay, let me give you an example. Let us say you have gone with your car into a garage. There is some fault in your car and you have taken it to the garage. So can there be possibility that 2 or 3 mechanics are working on the same car? Is there any possibility?
नो सर,
Yes, sir.
No.
Yes.
पॉसिबल है ना.
मेरे वहाँ तो
अभी
नहीं
लेट
है
अस से
possible.
किसी को बैलेंसिंग करवाना है अपनी गाड़ी का, तो एक बंदा क्या करेगा, डायरेक्शंस देगा. ठीक है, वन ऑफ द पर्सन विल गिव द डायरेक्शन, थोड़ा आगे लाओ, थोड़ा इधर लेके जाओ. सेकंड पर्सन व्हाट विल डू, ही विल बी ऑपरेटिंग द रिमोट कंट्रोल्स, थोड़ा ऊपर लेगा नीचे लेगा. सो व्हाट दे आर डूइंग, although there are 2 or 3 persons, but they are serving only one person at a time. Yes or no? भले यहाँ पर आदमी दो है बट दे आर प्रोवाइडिंग सर्विस टू ओनली वन कस्टमर. ऐसा नहीं है, देर आर टू पर्सन्स एंड दे आर प्रोवाइडिंग सर्विस टू टू पर्सन्स. There are two mechanics who are serving the same car. So that's why it is a single server model. Logic समझ में आया? Why it is a single server?
हाँ सर समझा.
ठीक है. So that's why it is a single server. Okay. What about queue length and what about the
सर
population?
फाइनाइट है, क्यू लेंथ फाइनाइट है और पॉपुलेशन मॉडल भी फाइनाइट ही थे.
हाँ से
इनफाइनाइट
मालूम पड़ा, देख लिया क्या? आंसर मैंने डिस्प्ले कर दिया था.
नहीं नहीं, मैं देखा ही नहीं, मैं डिस्प्ले बंद है.
ओके, लॉजिक बताओ क्या हिसाब से तुम बोल रहे हो कि इट विल बी अ फाइनाइट पॉपुलेशन
सर
मेथड.
देखो गाड़ी है मतलब अभी आपने जब गैराज का एग्जांपल दिए
ठीक है.
तो वहाँ पे आपने बोले मतलब वॉशिंग वाले के अंदर के मेरे पास
Good.
स्पेस इतनी है, एक ही गाड़ी की स्पेस है,
बराबर.
तो
ओके
मैं एक कोई क्यू में रोक सकता हूँ ना.
ओके, दैट्स
तो
गुड.
उसके हिसाब से अभी मेरी मशीन है, अगर मैं फोक आगे ये इमेज के हिसाब से फोक लिफ्टर है, फोक लिफ्टर
Okay.
मेरी खराब हुई तो मैं लिमिटेड ही फोक लिफ्टर ले पाऊंगा ना,
यस,
और
गुड.
जब पे लिमिटेड ही गाड़ी को वो कर पाऊंगा.
सही है, सही है. Okay,
रिपेयर.
so let me tell you that this is the example of let us say one of the industry. तो इंडस्ट्री का ये रिपेयर फैसिलिटी है, मेंटेनेंस सेल होता है, अगर आपको मालूम होगा. सो इन प्रोडक्शन हाउस देयर इज वन सेल नोन एज मेंटेनेंस सेल. तो मेंटेनेंस सेल में कौन आएगा? उस कंपनी की जो मशीन्स खराब होगी वही आएगी ना, कि बाहर की कंपनी की मशीन्स आएगी. सो द मशीन्स,
उसी कंपनी की मशीन
yes,
है.
that's why we can tell that it is a finite population method. Only those machines which are owned by that company or industry will be coming in the same company maintenance repair house. So that's why it is a single server, finite queue length and finite population model. Okay, one best example, I think this you can relate with you only. Okay, have someone identified this location?
सर ये अपने कॉलेज
KTC का.
Yes, it is a college lawn. And can you predict what this at what time I have taken this pic?
Practical के time से?
एग्जाम टाइम.
Yes, good. During exam
Viva
time,
के time.
yes, Viva time.
Wow.
You can see that all of them are studying. कोई कैसे तो बैठा है, कोई गेम खेल रहा है, कोई क्या कर रहा है, कोई क्या कर रहा है.
ये रह गया इधर.
हाँ.
वही तो टाइम रहता हम पढ़ते.
Yes. So this is the time at which on which I have taken this pic. So what can you tell about this image? About the type of model, finite queue length and infinite, or finite or infinite population? Tell me three answers.
सर ये सिंगल सर्वर रहेगा, और फिर अगर क्यू की बात करें तो फाइनाइट. अगर मैकेनिकल का प्रैक्टिकल एग्जाम है तो मैकेनिकल के बच्चे बैठेंगे ना.
Very good, very good.
पॉपुलेशन मॉडल जो है,
नहीं, वैसा एग्जाम्पल ले सकते हो तुम. फाइनाइट क्यू लेंथ के लिए मैं क्या बोल सकता हूँ, जो तुमने एग्जाम्पल दिया थोड़ा सा उसको मॉडिफाई करूंगा. लेट अस से in our class there are only 60 students, so that's why the length of the queue is 60.
हाँ सर, लेंथ ऑफ द क्यू 60
Length of the queue is 60, 61 person का लाइन नहीं लग सकता है. And what about finite and infinite population?
सर फाइनाइट है.
Finite
Yes,
ही
it will be finite
Mechanically
because if it is a let us say oral of operation research, जो तो होता नहीं है, but let us say it is an oral of operation research or any other subjects. So only those who have opted for that subject can go for that Viva. Electrical वाला, जैसे suppose for example let us say a subject is mechanical vibrations, और तुम लोग को वो नहीं था, let us say dynamics of machinery, DOM. तो डॉम के लिए सिर्फ मैकेनिकल के ME1 और ME2 के बच्चे ही एलिजिबल है. नो वन फ्रॉम इलेक्ट्रिकल और कंप्यूटर कैन कम एंड टेल दैट आई विल गिव द डॉम सब्जेक्ट वन. सो व्हाट इज इट इज हियर, इट इज अ फाइनाइट पॉपुलेशन मॉडल. सो दैट्स व्हाई आई रिटन हियर इट इज सिंगल सर्वर, finite queue length and finite population method model. So now I can assume that you will identify the type of models. Yes.
Yes sir.